Hi, my name is Husein Syed, and today we're going to learn about projectile motion by doing an FRQ on the topic. So the problem starts off by saying that you have been hired by a football team to use physics to improve their kicking game. During one of these kicks, you measure the angle of the kick to be 30 degrees with respect to the ground, and that the football travels a horizontal range of 52 yards. Here's a diagram of this situation. Part A asks, what was the range of the football in meters if 1 yard is equal to approximately 0.9144 meters? To solve this question, we will take 52 yards and multiply it by the conversion rate of 0.9144 meters over 1 yard. The yards will cancel out and we will be left with only meters. This comes out to be approximately 47.5488 meters. However, since we are using sig figs and 52 only has two significant digits, we can round this to be 48 meters. Now, in part B, we were asked, based on this kick, what initial velocity in meters per second is the kicker capable of giving to a football? To solve this problem, we will need to use the maximum range equation, which is r equals velocity initial squared times sine 2 theta over g, and rearrange it to solve for velocity initial. Now we have velocity initial equals the square root of r times g over sine 2 theta. Plugging in numbers, we can solve to get velocity initial equals 23 meters per second. Part C. Calculate the maximum possible range that the kicker could kick a football in meters. For this problem, we will be using the same maximum range equation again, but we don't need to rearrange it. We can leave it as the r equals. This time we will be using 45 degrees for theta because this is the angle required to find the maximum range. So now we have 23.196 squared times sine of 2 times 45, or sine of 90, over 9.8. This gives us a maximum range of 54.905 meters, which can be rounded to get 55 meters. For parts D and E, there's additional information that we need to know. This picture shows a regulation football field with the goalpost. The bottom bar of the goalpost is 3 meters above the ground. The coach wants to figure out the maximum field goal range. Part D states, based on the kicker's ideal kick that you calculated in Part C, how much time will it take for the football to reach the goalpost? To do this problem, we will use a modified version of a UAM equation. We will use delta y equals velocity initial in the y direction times time minus 1/2 gt squared. Using all the numbers from before, we get this quadratic equation. To solve for time, simply plug in the equation in a calculator and find the x-intercept. Doing this gets us t equals 3.2 seconds. Moving on to Part E, we were asked to use the time from Part D to calculate the maximum field goal range in yards. To do this problem, we have to use the UAM equation, delta x equals velocity initial times time. It is written as velocity initial cosine theta because we're solving in the x direction, and that is the proper component that we need. Plugging in numbers, we get x equals 51.711 meters, but we have to convert this number to yards to get the proper answer. To do this, we'll multiply 51.711 meters times 1 yard over 0.9144 meters, and the meters will cancel out, and we'll be left with x equals 56.6 yards. Thank you for watching my video.